Hi everyone, Mrs. Boyle here. In this video, I'm going to be going over the Boyle's Law notes. So with gas laws, we've been talking about three main variables: volume, pressure, and temperature. And we're looking at if we keep one of these variables the same, what is the relationship between the other two variables? So in Boyle's, with Boyle's law here, this is the relationship between pressure and volume. So a good example of that is a piston. So if we look at the two figures over here, so figure 1, when the temperature is kept constant, we are also keeping the number of moles or molecules or atoms, the amount of those are being kept the same during this experiment. So if we look at figure 1 here, if we put these molecules into a very confined space, so a very low volume. So by a confined space, I mean a low volume, a smaller amount of space, a smaller volume. The pressure is going to be very high because these molecules, they don't have a lot of space to move around. So they are more likely to hit the sides of the container. And if they're hitting the sides of this container, this piston, more often, that's going to create a higher pressure. So therefore, as volume decreases, the pressure increases. And vice versa. So if we decrease the volume, we create a smaller space. Molecules don't have as much room to move. The pressure will be higher. Versus if we give the molecules a lot of space to move around, a high volume, we increase the volume. They have more space to move around. They're gonna be less likely to hit the sides of the container. And therefore we will have a lower pressure. So it's very similar to what we saw in the FET here. So I'm going to keep the temperature the same, but I'm going to, if I decrease, so right now my pressure is at 6 atm. Let's decrease the volume, put them in a smaller space. Look, my pressure went up to around like 12 atm. So it almost like doubled, okay? Versus if I, let's go back to our original. So again, I'm at around 6 atm. Now let's give the molecules more space. Let's increase the volume. Look, the pressure went down by almost half, okay? They have more space to move around, so they're not gonna hit the sides of the containers often. So that creates less pressure. Versus if we decrease the volume, now they don't have as much space to move around. They're going to hit the sides of the container more often. And again, how often the molecules are hitting the sides of the container, every time they hit the side of the container, that exerts a force. That is what pressure is. So to summarize that, if temperature is kept constant, so the particles are moving at the same speed, they have the same amount of energy, they have the same kinetic energy, so they're moving at the same rate. And we can also assume that the amount or the moles, the gas particles, nothing's escaping or entering the container. So the amount of moles, particles, atoms, molecules, whatever, are being kept the same. As the volume, the size of the container decreases, this means the pressure would increase, because the gas particles would be hitting the sides of the container more often. since the space to move around is smaller. Again, the speed of the particles is being kept constant. But again, if we can find that space, they are going to hit the sides of the container more often if we decrease the volume. Versus if we increase the volume, this means the pressure would decrease. Because the gas particles would hit the sides of the container less often since they have more space to move around. So again, if I increase the amount of space, the pressure goes down. If I increase the volume, the pressure goes down because the molecules have more space to move around. Usually if we're representing this in a diagram here, the arrow length will indicate the speed. So if a arrow is longer, that's faster. If it's shorter, that means slower. However, in this case, the arrows are the same length. So that indicates that the temperature is the same between these two containers because the molecules are moving at the same rate. So they have the same temperature. Again, in this case, the one on the left here, there's more space for the molecules to move around. So this would have a higher volume and a smaller pressure, versus the one on the right would have a smaller volume but a higher pressure. All right, so this can be represented in terms of a graph like this. This is what we call an inverse relationship. So the volume of a fixed mass or amount of moles of a gas varies inversely with pressure when temperature is held constant. So this is what we call an inverse relationship versus the opposite of this would be a direct relationship, which would be represented like this. So for this formula, because this is an inverse relationship, we can say P1V1 equals P2V2. Now, what does that mean? This means the initial. So what is the initial pressure and temperature, or the pressure and volume, excuse me, that you're starting with, okay? So for example, for this simulation, my initial pressure would be around 6 atm, and then this does not have a measurement of volume, but however much space this container makes up would be the initial starting point for us. P2V2, this is the final pressure and volume. So this is after there's been some type of a change. So if I'm going back to the simulation here, this would be my initial situation, let's say, and then let's say I do this. Now my pressure would be, closer to 12 atm, and then my volume, it would be much smaller than what we started with. So that's all that means. Like, it's a before and after of some type of a change in the situation. For this situation, we're not changing the temperature, that's being kept constant. The thing that we're going to be changing is the volume, most likely. All right, so now let's do some calculations, some practice math problems.